For this video, we're going to talk about circles. Okay, just remember that we have two formulas, that basic formulas for circles, which are the circumference, which is 2 pi r, and then the area of a circle, which is pi r squared. Okay, now let's go to number 9. A circle has a radius of 28, so the r equals to 28 centimeter. And for determine the diameter of the circle, remember that the diameter is like twice of the radius, so the diameter is just 2 times 28 because the radius is 28. So that'll be just 56 centimeter, as easy as that. Okay, the circumference of the circle, since we know that we have this formula, so c equals to 2 pi r, and since we know that the r is 28, so that'll be equals to 2 times pi times 28, and that'll be equals to 56 centimeter. Okay, that's it. Oh, sorry, 56 pi, my bad. Okay, you don't have to change this into decimal, just leave it like that. Okay, next one is the area. So again, we have the formula here, so that'll be pi r squared, that'll be pi, and then 28 squared, and that will be equals to 784 pi centimeter squared. Okay, let's move on to number 10. From the image above, calculate the diameter of the circle and the circumference of the circle. Okay, so now we see that we have this guy over here, 7 centimeter. It is the radius of the circle because it is a straight line from the center point to the edge of the circle. So this is a radius. So the diameter is just okay. Since we know that the radius is 7 centimeters, so the diameter is just twice of that. So it's just like 2 times 7, which is equals to 14 centimeter. Okay, the next one is the circumference of the circle. So again, because we have that formula, c equals to 2 pi r, and since we know the r is 7, so that'll be just equals to 2, and then pi times 7, that'll be equals to 14 pi centimeter. Okay, next question, the area of the circle, the same thing. So since we have the radius, so the area will be just equals to pi r square, and it'll be pi times 7 square, and it will be equals to 49 pi centimeter square. Okay, next question, D is the major arc length of JK. So major arc length here. In here, I'm going to highlight something. In here, the first one is arc length. Arc length is going to be corresponding with the circumference of the circles because circumference. Sorry. So because if I say arc, it means that it's just part, the outer part of the circle. For example, like this one here, this line here, like the curvy line. This is arc. This is also an arc. Okay, so this is also the arc. So we have like, actually we have, if I say JK, you can have actually from here to here or from here to here. Both of them are JK. So, but how do you know that which one is which for this question? In here, it said that it is the major arc, right? So it means that they'll be the big one. So because the small one, we call it the minor. Here we're gonna go to later on in the question E. So for minors, the smaller one, the major is the bigger one. So the bigger one here, like this one and this one, right? So the biggest one is this one, right? So we're gonna use that one. So in here, what we need to do here is just compare the angle with 360 degree and then multiply by the circumference, because we know that it is corresponding to the circumference. And since we are going to use the big one, this one, right? So we need to find the angle over here, right? That angle. Let's name that with theta. So this angle here, since we know that this is 60 and we know that the whole circle is 360, so which means that the theta is just 360 degree minus 60 degree, right? Because the whole circle is 360 and this is 60, so this is the rest of that, right? So which means that the theta is going to be equals to 300 degree. So let's go back to the question again. In here, the major arc length, we have actually a formula for that, but the easy concept is this: just you only need to compare the angle that the arc made in the circle with 360 degree, because for the total angle of a circle is 360 degree. So maybe I'm just gonna write down the formula. That will be L stands for the arc length. It'll be equals to theta over 360. Again, the theta is the angle that is made for the arc, and 360 degree comes from the angle that shapes a full circle, and multiplied with by the circumference. Okay, or you can write this down as 2 pi r, but we don't really need this. I mean, like, we don't really need to use 2 pi r for this one because we already found the circumference, right? So here, oops, sorry. it's over here, right? So since we know the circumference, you don't need to write down 2 pi r. Okay, so I'm just gonna write down like this. Okay, so since we know that the this is the question in for the major arc, so the angle that we're going to use is that 300 over 360 degree multiplied by the circumference. It here is 14 pi centimeter. So just multiply this and you will get, that'll be 35 over 3 pi in centimeter. Again, guys, you don't really need to change this into decimal, this because this is the exact value. Okay, the next question is the minor sector area of G. Okay, so remember that arc length is corresponding to the circumference. When we're talking about the sector, it's correspond with the area, right? So the area of the circle. So basically it has a very similar concept like finding the arc length, but the only difference, you instead of multiplying with the circumference, you're multiplying with the area of the circle. Because if I say sector area of J, okay, it's gonna be like the area in here. And again, because it said it's minor, right, so it means that this is a smaller one. This is a small one. Actually, we have two. This is the small one and this one is the big one, right? So because it is asking for the minor one, so you're going to use this guy over here, right? So this area over here is going to be what we're going to calculate. Okay, now since we have the angle here, which is 60, so I'm just going to write down the formula first. So the sector area, that will be equals to theta over 360 degree, and I multiply with the area of the circle. Again, guys, a very similar formula with this one. The only difference is that for arc length, you multiply with the circumference. As for the sector, you multiply with the area of the circle. Since we already have the area of the circle, which is over here, so you don't have to calculate the area anymore. So in here, since we are looking for the minor one, so we're going to use the 60 degree. Let's go back again here. So this is 60 degree over here, right? And then divide this by 360 degree and then multiply it with the area. The area is 49 pi centimeter squared. It'll be 49 pi, and then just put all of this into the calculator. There'll be 49 over 6 pi in a centimeter square. That's it. Okay, let's move on to number 11. From the image below, if the minor arc length GH is 22 pi inches, determine the circumference of the circle, the radius of the circle, and the area of the circle. So again, guys, in here, what is being given from the question is the minor arc of GH. So we have G and H over here, and we have actually two arc. So this arc over here and this arc over here, right? So we have two arcs in here, but it said that it's a minor arc, so it's gonna be this one because this is a smaller one, right? So we're gonna leave this one over here. So this length over here, the length of this curve over here is 22 pi. So this is 22 pi inches. Okay, 22 pi inches. And then the first question is the circumference of the circle. So since we know that, we already got the what do you call it, the formula for this, the arc length. So I'm gonna rewrite the formula again. There will be L equals to theta over 360 and I multiply by the circumference. Again, guys, I'm not gonna use this 2 pi r because the first thing that we need the question is the circumference, so I don't need to change this. Okay, so basically you only need to like substitute all the values here, since we know that the L is the arc length and the arc length is this one, 22 pi. So just use 22 pi over here, like below the L in here, and the theta here is the angle that we're going to use for the arc, which is this one, 120 degree. So that'll be equal to 120 degree over 360 and then multiply by the c. Okay, so we can actually simplify this fraction here. There'll be 1 over 3, and since we can multiply both sides by 3 to make the c alone in one side of the equal sign, so I'm going to multiply both of them by 3. That'll be 3 times 22 pi, and then equals to, this is times 3 equals to 1, guys. So I'm just gonna use equals to c. Okay, so in case you wondering, I'm just gonna write down here that's 3 times, and you like times 3, right? Because you can actually cancel this, so that leaves c alone on the right side. So this one is still 3 times 6, 22 pi. So 3 times 22 is equals to 66 pi equals to c, and then don't forget that it is in inches, so you can just write down I and c. Okay. Next one is the radius of the circle. Again, we can correlate. We can relate the circumference with the radius. So since we know that the formula for the circumference of a circle is 2 pi r, so I'm gonna write down c equals to 2 pi r, because we know the circumference and we want to know the radius, right? So we need to like make a connection between those two, and we have this. And since we know that the circumference is 66 pi, so just write down 66 pi exactly below the c. Remember that this is a very systematic way on how to answer questions in mathematics. And it'll be 2 pi, and then since we don't know the r, just write down r here. So which means that we need to divide both sides by 2 pi, right? So divide this by 2 pi, divide this by 2 pi, and then you can cancel the 2 pi over here, and the r stays on the right side, and this is just equals to 30. Is it? Yeah, 33 pi. No, the pi is gone. Sorry, guys. Yeah, you can cancel the pi, right? So the pi is gone here, and 666 divided by 2 is equals to 33. So this is in 33 inches. Okay. The last one is the area of the circle. Since again we know the formula for the area of a circle is pi r squared, and since we already know that the r is 33, so just plug that in into the r. There'll be pi times 33 square, and if you put that into the calculator, you'll get equals to 1089. And don't forget that we have square inches, right? So inches square. Okay. Okay, moving on to the next question. From the image below, points A, B, C, and D are on the circumference of a circle. If angle ABD is 54 degree, what is the size angle X, and give the reason? Okay, so in here, what we need to write down first is the angle of ABD, which is 54, which is over here, right? The ABD, right? That'll be 54 degree, right down here. And what we're looking for is this angle over here. So based on the circle theorem, like this, I'm gonna write down here, guys. So the angle in the same segment, wait, let me just click that. Okay, so angle in the same segment here, theorem, are equal. So if I say we have this AD as like a segment like this, right? So we can, you don't actually need to draw the lines, but actually we can like, because this point B and point C, right? If you drag drag a line from A to B and then D to B, and also A to C and D to B, all of them are going to be making the same exact angle. So value of X is just equals to 54 degrees. So this is the reason why it's going to be equals to 54. So for example, if I have another point, let's say it's over here, let's name that with E, and if I drag a line from A again to E and then D to E, this angle over here will also be equals to 54. In number 14, given a circle below, point A is the center of the circle. So this point A here is the center of the circle. Line segment CD is the chord of the circle. So line CD is this one over here. This is a chord. And the angle AED is 90 degree. AED, so this one here is 90 degree. And then if the length of CD is 26, so the length of this line over here is 26. If the length of this line CD is 26, so I'm gonna just write down here, this is 26 centimeter, and AE is 8 centimeters, so this line over here is 8 centimeters. And calculate the radius of the circle. Okay, so the radius of the circle. So again, guys, the first thing you need to do to understand is what is actually a radius. So which one is the radius? Here in here, actually we don't see it. I mean, like you don't see the line. So if you don't see the line, make the line, right? So you can actually add. Remember that radius comes start from the center point of the circle and then going straight into the edge of the circle. So I can just drag a line, for example, like from A to D or from A to C. Both of them are the radius. So you can actually draw like this, right? Anywhere you want. But in here, since we have that point D and C, so use them so that we can calculate yeah, the radius. Okay, now in here, guys, as you can see that we have a triangle, right? So we actually have two right angle triangles, so they are exactly the same. Actually, I mean, like this, the measurement is the same. It's only like one is like flip to the other. So I'm just gonna drag one circle, not one circle, one right angle triangle from this two. So I'm gonna just like use this one here, 1 2 3. For example, I'm gonna use that one, right? I'm gonna move that here, right? So that will be, this point is gonna be A, this one is going to be E, and this one is going to be D, and this is a right angle triangle. So what do we know from here? I'm going to just erase this, guys. Okay. And what do we know from this AED? The first one is we know that the length of AE is 8 centimeter, right? So just write 8 centimeter over here, right? This AE. This is AE. And then the next thing that we know in here is actually the ED. So as you can see, that CD in here is 26, and it's like, if this is a perpendicular, this is actually going to be half of that. So because they are the same thing, right? So from C to E, I mean, like these two triangles are the same in measurement, so which means that the CE and ED are going to be the same. So when we want to find the length of CE or ED, we only need to divide this by 2, right? So 26 divided by 2 is equals to 13. So this is 26 divided by 2, and that'll be 13 centimeter. Okay, now to find the radius, this is radius, right? Here, this one is radius. So in here, we can actually use the Pythagoras formula. So because this is a right angle triangle, so we're gonna use that. I'm gonna write down the formula. That'll be c squared equals to a squared plus b squared. Okay, just remember, guys, if you are going to use this formula, the first thing I need to see in the image or the right angle triangle is to determine which one is this z value here. So the z value here is going to be pretty crucial. You don't want to mix up that with the a and b. The A and B, you can swap them around, but the C you can't. Okay, so the C is going to be the longest side, or what we call the hypotenuse. It's always going to be in front of the 90-degree angle. So this is going to be the R. So the R is going to be the C value in here. So the value of A and B doesn't matter which one, which is 18 or 13, right? For using the Pythagoras formula, I'm gonna, for example, I'm gonna use A for this one, and this is gonna be, you don't, I mean, like, you can swap them around actually. Okay, so the C, because the C is the R value, I mean, like the R, the radius, so I'm just write down R squared equals to A squared, will be 8 squared, and then plus 13 squared. Okay, and then you can just like put this into the calculator, guys. That'll be 64, and that'll be 13 squared is going to be 169, right? And then you only need to add those two numbers, and you will get 233, right? And then I mean, like, square root both sides, that'll be square root of 233. If it doesn't say anything about like changing the form of the final result, you don't have to. I mean, like, if this is the simplest form, you can just like put this number here into the calculator. If you press equal sign, it say like that, you don't have to change anything. So that'll be in centimeter. That's it.